I'll be slightly deviating from the regular scheme of things. Am I audible? Today I'll be slightly deviating from the regular scheme of things because I thought discussing about product teardown will be useful for your design appreciation lab also. I mean, somewhere down the line we must see this, but I'm bringing it slightly to the front so that this will be useful. This will be useful in your design appreciation lab also. So what we are going to discuss about today is a concept, an idea called product teardown. Tearing something is, you tear a paper. Okay. So you bring it to pieces. Similarly, we dismantle, or rather some people use the term dissect products. Dissection is generally a term reserved for biological applications. You dissect an insect, you dissect a frog. Okay. But also we do dissect products. What is the objective behind dissecting a frog or dissecting a cockroach?
Internal parts.
See its internal parts. Why should I see the internal parts? To know about it, to know how it works. Okay. The respiratory system of a frog, if you want to study, or digestive system of a frog, if you want to see, probably you may have to dissect and then see the internal components. Similarly, in mechanical engineering also, we basically are interested in knowing how the product works, how the whole product works. To do that, we may have to again do the dissection. Okay. Now, what can be the basic objectives of product dissection? Okay, next slide. So today, all that we are going to discuss about is how we are going to do this product dissection. In fact, this is what you do ultimately in your design appreciation lab. So I thought I should talk about it because many of you have started doing it. If you understand this better, probably you'll be doing that lab exercises also in a better way. So I thought I will discuss about product teardown exclusively in this class. Now first, why should I do this dissection? There can be three objectives. There can be three different objectives from different perspectives. The first objective is dissection and analysis as part of, or I'll first go to the second point. I'll first take up the second point. The second point is experience and gain knowledge. You take a product, you have a product. Okay, that is why you do product dissection in your design appreciation lab. Okay, you want to just dissect it, you want to dismantle it, see what all the different parts, how the whole system work. Okay, and this gives you an immense knowledge. When you dismantle, when you see the various parts, how they work in harmony, when they are put together, how they produce some beautiful results. Okay, so this gives you an immense knowledge about the individual parts as well as about the system. So this can be one objective of doing product dissection. I can dissect a product to gain some personal knowledge. That's why you are doing it in your design appreciation lab. I gain a knowledge about the various standard components. Okay, what are the various simple standard components used in a complex product? I gain an insight about that. Not only that, how two or more things come together and then work beautifully to produce a particular end result. Okay? So how? See, first we have just two questions basically when you dissect a product. First question is what? What this particular component does. What is the role? Then comes the question of how this does that particular job. Okay. What is the role of a particular product, a particular component, or a particular sub-assembly? Then comes the issue of how it does the job. Then probably there are many other issues. Depending on your curiosity, you can learn more things also. How each product is being manufactured. Okay. What is the material with which each product is made up of? Can I use some other material in this particular place? I mean, and what is the cost of the product? What is the cost of each component? Because the cost of each component put together contribute to the cost of the product. See, when my computer itself costs me about 40,000 rupees or 25,000 rupees, a PC costs me 25,000 rupees, I cannot have a keyboard which costs me 2,000 rupees. No. Keyboard must cost me typically some 300 rupees or 250 rupees. When the cost of the computer itself is 25,000 rupees, my keyboard cannot cost me 2,000 or 3,000. A typical keyboard costs around 300, 350 rupees. So that means what is the cost of making each individual keys? There must be a springing back. How am I going to achieve that? What about the electronics of it? See, cost is a very important aspect in engineering. Okay. So, how can I reduce the cost or cut cost? How can I simplify my design? So, it depends on your curiosity. You can go further deep. So, what purpose of doing dissection in mechanical engineering is? Dissection of mechanical products is done to gain some personal experience and knowledge. Is it okay? Are you getting it? It is to gain some personal experience and knowledge. Sir, are you able to understand? Back to the theater. The purpose of doing this dissection, one objective is to gain some knowledge about the components, about the process, what it does, how it is manufactured, what are all the materials with which it is made, how can the cost be reduced, all that. Is it okay? Now the second thing, the first point in the list, dissection and analysis as part of reverse engineering. Here I am introducing another very interesting concept called reverse engineering. What is reverse engineering and what is forward engineering? Okay, I mean, there is something called reverse engineering. That must be regular engineering, normal engineering. Is it okay? In normal, regular or forward engineering, there is nothing called forward engineering. Please take it from me. Only in contrast with reverse engineering I am telling that. In normal engineering, the sequence of operation is like this. You design a product, you manufacture it, you use it. Am I right? In normal engineering, you design a product, manufacture it, then use it. In reverse engineering, what we do is, you already have a product. From the product, you think whether I can get the design. I can see many people smiling, sir, this is nothing but copying. Is it not? You have a product, from the product, I just go back, take the product, dismantle it, get every parts measured, get the drawing, and see whether I can get the complete design. Do you understand? Please take it from me, this is not copying. Reverse engineering is a subject by itself, is an engineering subject by itself. See, there is a beautiful saying which goes like this. There is no need to reinvent a wheel. What do you mean? See, wheel is an engineering component which was designed, which was conceptualized, which was developed some 3,000, 5,000 years ago. Okay, I didn't invent the wheel. So I cannot go and say that I will start from the wheel. I will go and reinvent it first. Then I will proceed. I cannot start from scratch. In scientific technological development, I cannot start from scratch. See, in this particular domain, my knowledge is, see, for example, let us say in nanotechnology, you say, the knowledge available in India is very poor. Let us assume for the time being. So, how can I increase my competence in nanotechnology? First, I must know what is the prevailing status in nanotechnology. That I must try to grasp. Okay? What is the state of science, state of the technology in nanotechnology as on date? That I will try to understand, grasp, then I can start from that point onward. Okay? This is true for anything. Suppose I'll tell you a real case. We are very poor in developing engines. Okay? Especially we are very poor in developing aero engines. Kaveri was the engine which was intended for LCA. Kaveri was the engine which was intended for LCA. It was not a successful venture. It had a lot of problems. So I want to develop a suitable engine for aero applications. I want to develop a good jet engine for aero applications. So what should I do? I cannot say that I'll start from scratch. I cannot start from scratch. I should first know what is the prevailing engine technology. I should make myself familiar with that first. Then I can probably try to add something more, arrive at my own design. This is the way technology can be developed. So, reverse engineering is an accepted engineering practice, provided you don't violate any copyright law. If something is considered as a unique invention of a particular company, that I should not duplicate. Otherwise, the technology is for everybody. Technology is developed by standing over the shoulders of others. I am able to see more because I stand over the shoulders of others. Who said this? Find out. Okay. I am able to see more because I am standing over the shoulders of others. This is how science and technology develops. So, what you have to do is, when you want to develop knowledge base about the state of our technology, about a particular product, you have to do again what is known as reverse engineering. An established procedure for reverse engineering starts with dissection. Here. Now the third purpose for doing teardown is competitive benchmarking. What is competitive benchmarking? Competitive benchmarking is, see, I am manufacturing a particular product, but the same kind of product is being manufactured by so many other players also. So naturally, in the market, I must understand how my component, my product performs vis-a-vis my competitors. So this particular idea is called benchmarking. Benchmarking is, of course, I'll be talking about reverse engineering and benchmarking in detail later. But benchmarking is, you have 3-4 products prevailing in the market, being produced by different players in the market. Now I want to know how my product performs vis-a-vis the other players, the product by other players. So this is called benchmarking. So for that also, I must take all the competitors' products, do a tear-down analysis, and then arrive at the way my product is going to perform, where my products perform better and where they are not so better. That I must have a very clear grasp. That is done by competitive benchmarking. So these are the 3 instances wherein you need to do a tear-down analysis. Next slide, please. Now what is the tear-down process? How to proceed? How to proceed in a systematic way and then do a dissection. Okay. Now first, I must identify what is the design issue. What is the basic objective that I want to achieve by doing the dissection? So that is the first step. I must clearly identify the objective of the process. Number 2, you have to prepare for product tear-down. There are many preparations that are required. For example, what are all the things that you want to measure? When you do the tear-down analysis, depending on the objective, if the objective is reverse engineering, then I may have to measure all the dimensions of individual components and then probably generate a design itself. If it is benchmarking, then I may have to see how each subsystem of the product performs and then compare the performance of my product vis-a-vis the various products. So I must make a very clear preparation for doing all these testings. I don't know, am I making sense? Are you able to understand? See, if you want to reverse engineering, what will you do? Not do the products. Okay, take individual components and measure, prepare a CAD drawing, okay, using AutoCAD or better softwares. Okay, so that I can finally arrive at the design, complete design. I want to benchmark. Then you dissect your product as well as your competitors and then see how the various subsystems perform. Okay, suppose I want to do my engine. I want to compare my engine with the engine of my competitor. Then what should I do? I should first see how the friction reduction is one area. What is the friction between the piston and the cylinder in my engine, and what is the friction between the piston and the cylinder in the competitor's engine? What is the brake horsepower that I am getting in my engine, and what is the brake horsepower I am getting in the competitor's engine? What is the maximum acceleration that I can get in my engine, and what is the maximum acceleration I get in the competitor's engine? Suppose I identify in everything else my engine performs better, but in the acceleration my engine is not performing better. the acceleration produced by my design is very poor, then probably I can go deeper. Why the acceleration is not very good? Okay, the acceleration is not very good because the mass of my piston is high. Do you understand? When the mass of the piston is high, it cannot accelerate easily. It takes time to accelerate. Or mass, not necessarily the piston, mass of the moving parts or the mass of the flywheel is higher. Okay? Or mass of the whole system is high. So I am not able to provide the necessary acceleration. You have to identify. So that way I can do benchmarking, and that leads to product improvement. I can make my product to perform really better. Okay? So I have to prepare for all these tests. So if I am going to measure friction, then how I am going to measure friction? I may have to prepare a plan for measuring friction, and I must make necessary arrangements. So these are all the preparations that I may have to do before going for the dissection. Then examine distribution, packaging and installation. Many times the distribution procedure, packaging procedure and the installation procedure followed by the manufacturer, that gives you a clue of what are the parts hidden underneath. Okay, so you have to very closely examine what is the distribution procedure followed, packaging procedure followed and the installation procedure followed, because you should not damage this. Once these informations are lost, retrieval becomes very difficult. Then you have to dismantle, measure and analyze. You have to dismantle, measure whatever you are interested in, and then you have to analyze it. Then you have to form what is known as the final, one of the final outcomes of a dissection process. It can be different, there can be different outcomes. A complete drawing itself can be the outcome. Complete design itself can be the outcome of a teardown process if it is reverse engineering is objective. One of the outcomes is you have to form what is known as a bill of materials. I'll explain what is bill of materials. Okay, this bill of materials is something you have already heard about bill of materials. No, probably you will learn about bill of materials in your AutoCAD. Okay, bill of materials is a simple table. Bill of materials is a simple table. Okay. Bill of materials is a simple table. So first you will have part number, part name, number of, and material. So this is a simple bill of material. This is the basic document. Of course, I am going to show you some other formats for bill of materials also, but this is the simplest of all. Are you able to see it? Yes? No. Then probably I will write it bigger. There are 4 columns. The first column is part number. Now are you able to see? Yes. The first column is part number. The second column is part name. The third column is number of. I'll explain what each are. And the fourth column is material. This is the simplest form for making the bill of materials. Okay, this is the simplest form for making the bill of materials. But there are nowadays the whole design process is being controlled by the softwares. So different softwares, they provide you different ways of generating bill of materials. For example, any modeling software, it has provision for preparing the BOM. Okay, bill of materials. Every software has a provision to prepare its own bill of materials. So it has a certain additional features also. So your dissection process, it culminates in preparing the bill of materials. Is it okay? Now go to the next slide, please. Now, many times, when you do a teardown process, you dismantle the various products. And then position them in what is called an exploded view. Of course, you can do it in two ways. Physically doing it is difficult, but you can do it digitally. When you generate a model and then assemble it in, say, a modeling package like Pro-E, okay, you can generate an exploded view like this. So you have so many parts coming into a differential. Okay, if you clearly study a differential, you have so many parts which are going into a differential. Okay, so you have to arrive at, when you do a teardown process, you must identify all these, and then you have to arrive at the bill of materials. Of course, I will take a product and then I will do a case study, and I will give you an assignment on doing. I will do for one product and then I will give you an assignment. That will be your second assignment for this term. This term we are supposed to have 4 assignments. One is over. The second assignment for the term will be given. That will be on preparing a simple exploded view and bill of materials for some of the standard parts. Is it okay? Now, before I proceed further, now the most important step, can you please go back to the previous slide, sir? Now the most important step in the whole teardown process is disassemble, measure and analyze. Okay. Now how I am going to analyze the various parts of a particular design? The most important step is to analyze the whole design. Is there any systematic way by which I can analyze a particular design? This will be particularly useful when I do reverse engineering or when I do the competitive benchmarking. So now when I do this analysis, this analysis is performed by a process called SOP. By a process called SOP. Now the expression for SOP is subtract and operate procedure. while analyzing a product teardown, now I want you to understand this very well. Okay, I want you to understand this very well because I want all of you to do at least some rudimentary form of this SOP when you do the design appreciation lab. Now, what is the essence of? It is a 5-step procedure. The SOP is subtract and operate procedure. Subtract and operate procedure. What is the idea behind the subtract and operate? What is the principle? It has 5 steps to be carried out. What is the basic principle? Okay. The basic philosophy behind this SOP is you will appreciate a value of something only when you lose it. You will appreciate the value of something only when you lose it. Okay? Only when you come to the hostel, probably you will understand the greatness of your mom. Okay? Okay? The taste of the homemade food, probably you will appreciate only when you eat in the canteen. Okay? Only when you miss something, the moment you take, when things are available to you, you take them for granted. You don't really appreciate their real value. Only when you miss something, you will really appreciate the value of it. That is the basic philosophy behind subtract and operate. So what you are going to do is, suppose say a product has 10 components. A product has 10 components. Of course, in real life, a product never has a simple architecture like 10 components joining together to form a product. Usually what happens is, 3 components will join together, form a sub-assembly. Another 4 components will join together, form sub-assembly 2. Sub-assembly 1, sub-assembly 2 and 3 more components will join together to form a finished product. Let me take a simple case. Can I have your pen, please? Okay, this is a pen. Now this pen is a product. Now what I'm going to do? I'm going to do a dissection of this pen. Okay, I'm going to do the dissection of this pen. Now, so this is the cap. Okay, this is the body. And this I call it as a cap sub-assembly. This I call it as a body sub-assembly. I do the naming as per my convenience. This is the cap sub-assembly. This is the body sub-assembly. Is it okay? Now this body sub-assembly, it again consists of, okay, there is something called a refill sub-assembly. Inside the body sub-assembly, there is something called a refill sub-assembly. Why I call this not just as refill, but refill sub-assembly? Because it contains multiple components. It contains, immediately if I see it, it contains, okay, for me it appears it contains 3 components. So let me come back. Please don't worry, I'll give you your pen intact. Okay. Now, let me take a refill sub-assembly. In the refill sub-assembly, okay, I have again 3 components. One is the tube, number 2 is the ink, number 3 is, okay, nib sub-assembly. I don't call it as a single part. I call it as again a expensive sub-assembly, of course. Okay, because it contains two parts again, a ball and a ball holder. Do you understand? It contains a ball and a ball holder. Now can I recreate this? Let me now confine my analysis to this. Let me recreate this. Now, first, what I am doing is I am drawing the product architecture. What do you mean by an architecture? How different parts are put together to finally arrive at the product. Now, what I have is say refill sub-assembly. Those at the back, if you are not able to see it, you may have to catch up with my pronouncing it. Okay, this is refill sub-assembly. Are you able to see it? I am happy. Now, what are the parts which are coming into refill sub-assembly? Tube, ink,
Nib sub-assembly.
Nib sub-assembly. Now this nib sub-assembly consists of holder and holder. And this ball and the ball holder, they have to be assembled in a particular fashion. I cannot dismantle it and then give it back to her safely, so I am not doing it. While doing the dissection, you must be careful about that also. Okay. So then how can I show you the ball? No, I cannot. Probably I'll try to take an image of it tomorrow and then bring it to you. I can do that. Okay, we have provisions in our labs wherein I can take an image of this ball and then show it. So that is what I mean by the preparation. Okay. So there is a ball at the tip which rotates and which is coated with the ink, and that ink is being subsequently transferred to the paper. Okay. So this is the architecture of the refill sub-assembly. Okay. Now refill sub-assembly, then now the refill sub-assembly, then I call this as top closure. I don't know, I don't have a better name, so I just call this as top closure. Then there is something at the bottom, I call it as bottom closure. Then there is the center body, and please remember there is something, a blue color one here. What is it? It is a gripper. All these things together. So this is body sub-assembly. Is it okay? So body sub-assembly and cap sub-assembly. In fact, I should not draw the cap sub-assembly here because that has many parts. So cap sub-assembly together, I have my pen. Now I have drawn the architecture of my pen. This is the product architecture of my pen. Is it clearly understood? Now, what is the next step? The next step for me is to prepare the bill of material. Now what I am going to do is, I am going to prepare the bill of material. Okay. So let me do. So first, part number, name, number of materials. Is it okay? What is part number 1? I mean, part number, many times it is linked with the drawing number. So every organization will have its own drawing number. It has some rational behavior. Because the moment I see the number, I should be able to, it should tell me some message. For example, your RRN number. Does it have a rational? Yes, it does have a rational. Some digits indicate your year of admission. Some digits indicate your branch. You understand? The fourth digit probably it indicates your branch. Am I right? I don't know. The fourth digit of your RRN number, it indicates your branch. The last three digits are students within that particular branch. And you have some number representing the year of admission. You all have your number starting with 11, is it not? 2011 is your year of admission. So the moment I see the number, I should be able to identify, oh, this student belongs to 2011 batch. He is a mechanical engineering student. His number is 128. Something like this. So similarly, the drawing number will also have its own rational. It can be a 10-digit number, it can be alphanumeric, it can be pure number, it can be anything. So it will be the drawing number many times, part number. Then name is that. Okay, name. So let me start from the holder. How many holders are required? One holder is required. And what is the material? The material can be steel. Then the second part is ball. How many? One. And what is the material? Yes. Steel. Any objection? Brass. No. Now, can you recall some of the advertisements of Reynolds or some other? No. Tin? No. No. No lead. No, I give you a clue. Can you recall some of the ads? What do they claim? Can some of you see your pens? I don't know. Some of the pens may also have the tea. What is it written there? Here it is written there. Can you please read it alone? No, after that. Fine carbide. Is it carbide or something? See, the tip is made up of metallic carbides. Because if people claim that they must run for, that must ride for kilometers. Okay? So it undergoes enormous amount of wear. When I write it on the paper, of course paper is also a piece of material. Okay? Imagine what will happen if that ball loses its shape. Why your pen doesn't write well? Ballpoint pen doesn't write well if you drop it. If I drop it like this, after that it won't write at all. Why? The ball gets slightly damaged, it loses its spherical shape, then it cannot subsequently roll easily. It is supposed to very freely roll. The moment I drop it, it loses its spherical character, so it cannot write smoothly. Am I right? Thank you. Generally, carbides and nitrides are abrasives. Silicon carbide, silicon nitride, these are all abrasives. Even metallic carbides, iron carbide, nickel carbide, these are all very hard particles. Fe2O3, FeC. Fe2O3 is iron oxide. I am not talking about oxides. What we are talking about is carbide. Fe3C. Fe3C is iron carbide. Similarly, I can think of nickel carbide, chromium carbide. So these carbides are very hard particles, and the bond must be made up of a metallic carbide. What metallic carbide? It varies from companies to company. That is where they have to develop their own material and then have it. So this is, say, metallic. So like this, the list can continue. Okay. So you have various materials and the list will continue. Do you understand how we prepare the bill of materials? Is it okay? So I have taken a product, I have done a tear-down analysis, then I have prepared the bill of materials. Is it okay? I have prepared the bill of materials. Next comes the most important step. That is the SO. That is subtract and operate. Why do I do this? The philosophy is simple. Unless I really lose something, unless I really miss something, I won't appreciate its worth. Okay? Unless I really lose something, I won't be able to appreciate the real worth of it. So, what you do is, suppose if your system has 100 components, one by one you remove and then see what happens. You have a standard 5-step procedure. The 5 steps are the 5 steps are the first step is subtract one part. Subtract one part. The second step is you operate. Then the third step is analyze. The fourth step is, from the analysis you deduce. You conclude something from the analysis. The fifth step is replace. The procedure for subtract and operate consists of 5 steps. Subtract one part. Okay. Then operate. Then analyze. What happens when it operates? You analyze. Then you come to certain conclusions. Okay. Then you replace that part and then go back. This is a loop. If the product has 10 parts, you have to do it 10 times. For all the parts you may have to do this exercise. The objective of this exercise is to appreciate the value of each part. Probably if you find some part is not having any value, then that can be removed, it can be thrown off. So this is the standard operating procedure. Standard operating procedure for doing SOP. SOP is an acronym for something else also. SOP is standard operating procedure. Okay. So here by SOP what we mean is subtract, operate, procedure. Subtract and operate, procedure. Now let me do that for the pen. Is it okay? First let me do. Suppose I can come from my bill of materials. What is the first part? The first part that I had, part number 1, holder. The ball holder. So if I don't have the ball holder, what happens? The pen will not work. Okay. If I don't have the ball again, the pen will not work. Okay. Let me come back to that. If I don't have the cap, the pen may work, but still I may get some. If I keep the pen in my packet, I may get some markings here. Okay. So like this, I can do the analysis for every part and validate whether that part, what it does. What is the functionality of that particular part? Is it okay? Now let me take one more product, do this complete analysis. Okay, I'll first draw the product architecture. Okay, then I'll prepare the bill of materials. I'll perform the SOP, and then we will close for the day, and probably I'll give you your second assignment by that time. Okay, let me take I have a list. Probably I will take shall I take the easiest or the toughest from the list? For me to do. So ceiling fan is the toughest as I see. Okay, ceiling fan is a product. Okay, see, please note, I won't be able to do full justice to it because the number of parts are very huge. Okay, that is why I eliminated this from the assignment. Okay, ceiling fan, I'm going to do only for 2 sub-assemblies of ceiling fan. Is it okay? I'm going to do 2 sub-assemblies of ceiling fan. Is it okay? One sub-assembly is blade sub-assembly. So what is the first step? First step, I have to draw the product architecture. Okay. First I take the blade sub-assembly. Now, the blade sub-assembly consists of first is the blade, okay, the blade sub-assembly consists of blade, okay, blade holder, washer, spring washer. Please take down, I'll explain what these things are. So these are all the parts that go into, in fact, wait a minute. The blade sub-assembly consists of a blade and a blade holder. Is it okay? Now, this is the hub sub-assembly. In the hub sub-assembly, you have washer coming, bolt coming, nut is there, then you have the So I'll explain what it is. First of all, you take a single blade. Okay? You take a single blade. If you take a single blade, it has a structure like this. A single blade, it looks something like this. Okay? Then at the end, you have this is the blade holder. This blade holder is used to fix this blade to the hub. There is a central hub in the fan which rotates. Okay. Of course, you don't have a fan here. You can probably check it at your home. This blade holder is attached to this blade by means of 3 rivets. There are 3 holes here. So it will have 3 holes here. So this is joined together by means of a rivet. You have 3 rivets going inside. A rivet is something like this. A rivet is something like this. What it will do is, they will keep this blade holder here, put the rivet, hold it at the bottom, and then no screwing. They will hit it hard, okay, so that this part will deform, and then it will, the blade and the blade holder are caught in between these two. Are you able to understand what I mean? Like bolts and nuts, like welding. Riveting is a metal joining process. When you want to join 2 things, okay, especially welding will not work when the thickness is uneven. One is very thick, the other one is very thin. Okay, your welding or any other method of joining will never work. All the skin of the aircraft is attached to the frame by means of riveting. Because the frame is a thick material. The skin is going to be a very thin material. Uneven thickness, when you have uneven thickness, welding cannot be done. The moment you try to weld, the thinner thing will melt and then flow away. You understand the difficulty? Okay. So there are only 2 options. One is called spot welding, which is very difficult. The other one is riveting. In riveting, what you do, all the bus body construction, the skin of the bus is attached to the frame by, what is the process? It is by a riveting process. So again the same issue. You have a very thick frame and a very thin skin, they are joined together. Riveting is the ideal process. Now how riveting is done? You have hole here, you put the 2 pieces together, put the rivet. The rivet will be something like this. Then there is a riveting tool. The riveting tool, what it will do is, it will hold from one side and then apply force on the other side. So this part will deform and then it will also become like a... So this is the riveting process. It is a semi-permanent joint. We don't want to, the moment it is assembled, we won't be able to separate them. We won't be able to dismantle them. Is it okay? So these 2 are joined together by means of, so how many blades is required? Please remember, you have to be very careful. For 1 blade sub-assembly, 1 blade is required, 1 blade holder is required, and 3 rivets are. architecture on the bill of material, later on I may have to do what is known as my material requirement planning, which is a huge task. MRP. Have you heard somewhere about MRP?
Maximum retail price.
What?
Material resource planning.
Oh, sorry.
Material resource planning.
MRP softwares pati kelippadudilla. MRP softwares, SAP, Oracle, these are all MRP softwares. That MRP is essentially MRP software, Oracle, SAP, these are all MRP softwares. Okay? So, that MRP is materials requirement planning. These are essentially MRP softwares. Okay, let's not go that far. Now, I have the product architecture. You have a blade subassembly. Then you have a washer. Now this blade subassembly is to be joined to the hub. So this is, say, at the center you have a hub. So 3 blade subassemblies must come here. Okay. How many washers will come? 2 washers, 2 spring washers, 2 bolts and 2 nuts and 1 hub. All this will join together. I'm sorry, 1 minute. So you have 3 blade sub-assemblies coming. So all this must be 6 washers, 6 spring washers, 6 bolts and 6 nuts and 1 hub. You have to be very careful while deciding the product architecture. Now let me try to do the SOP. Let me try to do the SOP. Now, is the blade required? Absolutely. Otherwise, there won't be any air movement. The blade holder is required? Yes, it is required. If I remove this and then try to operate, the blade will fly off. Rivets required? Yes, rivets are required. To hold these 2 together, rivets are required. Do I require a washer?
No.
Yes, you will appreciate it later. I do require a washer because the clamping pressure must be evenly distributed onto the surface of the blade. Otherwise, see, the idea of a washer is again a beautiful mechanical concept. The idea of the washer is when you tighten the bolt, there is something called the clamping force. That force must be distributed over an area. See, if the crux of mechanical engineering is you want always load to be distributed over a wider area. Otherwise there is stress, huge stress. If I have a problem and if I share it with many others, my problem will get reduced. If I have a huge load, if you distribute it over a large area, the stress is less. You know, stress is load divided by area. The load, I don't have any control because it is coming onto me. But what I can do is, I can have a large area over which this load is distributed. Then okay, I have a large area over which this load is distributed so that stress is minimum. So the washer does the job. It doesn't let the load to be concentrated at a few points. If the load is concentrated at a few points, then it may damage that local points. So the washer is an essential mechanical component. Spring washer, see, it is a rotating part. Have you ever imagined there is a bolt and nut? Okay, imagine for a moment if that bolt and nut, it is rotating, a lot of vibration is going to be there. If that bolt and nut got loosened, any bolt nut arrangement, they have a tendency to loosen. If they get loosened, what will happen? It will not fall. Please understand. When it is rotating, if it is loosened, what will happen? If the blade is loosened while it is rotating, in your class at peace if there is no spring washer here. Okay, the spring washer, what it does is, it exerts a constant pressure between the bolt surface and the nut surface, and it prevents the loosening of the bolt and nut. That is the purpose of a spring washer. You can probably dismantle. You can go to your home and dismantle a fan and clean it and put it back. Your mother and father will also be happy. Okay. You can remove the blade, and please be careful to put back the spring washer carefully. Okay, you can see a spring washer there. Okay, and that prevents the loosening of the bolt and nut. Now again, there are many parts. Okay. Now in the top of the fan, also there is a. I will not do the. I mean, you understand what I mean by the subtract and operate procedure. Now let me come to, since I have started talking about fan, I would like to just say one more word about it, and then we'll go to the assignment. Now if you see the fan at the top, so this is the ceiling. Ceiling line, you will have a U. Okay. So the side view, it will be something like this. Okay. Your fan will have a fork like this. You put a bolt and then tighten. What happens if this loosens? The whole fan will fall. How will you prevent that? Is it protected? Is it safe in your house? How? Can somebody tell me? Now, in this bolt arrangement, I don't know how many of you have seen it. In this bolt arrangement, this is the bolt, and you will have the nut here. After that, there will be a small hole, and there is something called the split pin. It is something similar to a hairpin. You insert it and open it on the other side. So you insert a hairpin, and then the free ends are opened out. So it will be something like this. So in the unopened position, it will be like this. After it is opened, it will be something like this. This is open. So this cannot come out. So even if the nut is loosened, it cannot travel beyond this particular point. This is called a split pin. This is again a very useful mechanical component. Please remember, so much of engineering has gone into designing a simple fixture for a fan. That is why we could take it for granted and then do our work at ease. You understand? So I want you to do the sort of subtract and operate procedure for some of the components that I am going to give as an assignment. Okay? Roll numbers ending with 0 and 6. Roll numbers ending with 0 and 6. The product assigned for you is an electric tester. A handheld electric tester. Roll number 0 and roll numbers, RRN numbers ending with 0 and 6. A handheld electric tester. I have seen to it that it doesn't have more than 10-12 parts, so that you can do the analysis easily. Roll number. Sorry. No, let me. Roll number 0 and 5. I'm sorry. Roll number 0 and 5. It is electric tester. Probably you can buy one for 20 rupees, open it out. It is worth it. Roll number 1 and 6. A liquid soap dispenser. Liquid soap dispenser. 0 and 5. Voltage tester. Yes, any doubts? I'll tell you what you have to do with all this. Roll number 1 and 6. Liquid soap dispenser. I hope you understand what I mean by this. Don't say at the end of the week, within a week, you have to submit this. At the end of the week, please don't come and say I don't understood what the product is. Liquid soap dispenser, huh? See this Dettol and what else? Lifebuoy, they all come with the dispenser. Okay. So number 3, 2 and 7 is common ink pen. Common ink pen. 3 and 8 is 3 and 8 is a 15 amps plug. A 15 amps plug. Okay. 4 and 9 is, yes, we have a suggestion. It is a 15 amps socket. Is it okay? Of course, a 15 amps socket we have not more than 10 parts. Okay, I have ensured that in all this you don't have more than 10 parts. Take it very seriously. I want you to do 3 things. Listen carefully. I want you to do 3 things. First thing, you must draw a product architecture. You give names as you please. Again, no copying, no sharing of information. All of you, it is worth spending 10 rupees, 20 rupees, 30 rupees. Buy these products. You open them up. Draw the product architecture. First step. Second step, prepare the bill of materials. The whole thing must come within 1 page. If you want to take a photograph of an exploded view, original photograph, that can be included. Don't download and just give it to me. You have prepared an exploded view. If you want to take a photograph, you can take it and include it. Okay. So, you have, the first step is product architecture. The second step is preparing the bill of materials. The third step is SOP. So, you remove each and every part and see what happens to the whole functionality. This is a small exercise. Please remember, this is what exactly you are supposed to do in your design appreciation lab. In your design appreciation lab, you can go steps further and then see what is the material in which it is made up of, how it is manufactured, okay, what is going to be the cost issues, all that. Can I have the next slide, please? Okay, this is an exploded view of an engine. Next slide, please. This is an exploded view of a hard disk. These products I didn't give you. You should thank me. I had all these ideas, but still I didn't give you. Okay. So this is a hard disk exploded view. Next. So this is a typical. Please view carefully. This is a typical bill of materials when you work in Pro Engineer. Pro Engineer, it facilitates you. When you assemble in Pro Engineer, you make hundreds of components. So, you make hundreds of components in Pro Engineer. You assemble them to have a sub-assembly. You assemble sub-assemblies to have the assembly. When you prepare an assembly, automatically the BOM is created. The computer does it. Okay, how many rivets I am using? Rivet drawing I have made, bolt drawing I have made. How many bolts I am using in the assembly? The system must know. So it will automatically, the part number of bolts, the system must know. So it automatically generates the BOM. Okay, so this is a typical BOM of the available in Pro Engineer. Like this, any modeling software will have its own BOM format. Unigraphics, they have their own BOM format. Next slide, please. Any questions? Okay, if not, I have a small video, okay, that will explain the teardown process for an engine, for a two-wheeler engine. Probably I am going to show you. It consists of 3 parts. It's a lengthy video. I'll show you only the first part. The other thing is for you guys to go and download or see. No. I'm sorry, we don't have an audio. Can somebody tell why it is so difficult to remove this particular part? So rotation and the locking direction of the thread are one and the same. So in the process of rotating itself, it will get locked. It is designed in such a way that the direction of rotation and the locking direction of the nut are one and the same. So that in the process of rotation, it doesn't loosen. So now to dismantle it is very difficult. See again, it is not a proper behavior. Okay. See, if you are not interested, it is up to you.